Hey guys, how are you doing? We, you know, already got lecture 10. It's a great thing. Actually, but I made almost 10 lectures, but so sad right now. Nobody, see it, my lecture. But uh, yeah, I I'm pretty sure time goes by, you guys will someday notice this lecture and will, communicate with me this, lecture, and we will be a super smart electrical engineering, by the way. So today, um, the subject is the cause of the breaker contact damage. Okay, let's see. The answer is magnetic force. But as I said, there's two ways, positive and negative way, right? So I will say negative magnetic force is it will damage the breaker's contact. Let's see more. There's many kind of breakers, right? So look at that. Here's many kind of breakers, and this is the range. You know what I mean? Every has a every CBS has their own range. So different range. So yeah, just check it out. And this is a oil circuit breaker. As you can see here, inside it filled up with oil. And this is VCC. No, VCB, vacuum circuit breaker. Look at it, here's a vacuum, right? So let's move on. So you look at that. Uh, as you can see here, uh, generally, the contact part is look at that like this. One side is fixed, one side is moving. Generally, or some breakers, the contact is both of them they could move. But generally, what I'm saying is one part is contact fixed, and this is moving. Okay, and between them, there's some compression powers. So it gotta be like a compression between them. You know what I mean? So let's go over. Oh, people are moving out. Look at that here. Uh, Circuit breakers' main purpose is to cut the current, right? And make it open, right? So it generally, as you can see, normally closed. And when it operates, when it runs, it opens the circuit. That's the mechanism, okay? Let's see more. I will. Okay. Here, look at that. Uh, so I said that the contact is here, right? As you can see, I will see. The contact is since, for example, the current I, you think in the circuit, like you guys think of current as flow like this? Of course not, because it made it by metal thing, yeah. So look at that. So it's only connected one dot point. Okay, I expanded this. Okay, what I mean is like one dot point is connected. Okay, so look at that. This is also simple thinking like waters flow like this, right? And well, sorry guys. So check it out here. If you guys remember the previous lecture, as I said, on the conductor, if there's two different direction of a current, flows, what happened? You guys remember? One. I will give you 3 seconds. 1, 2, 3. Yeah, that's right. Yeah, electrostatic repulsions happened, right? If you guys didn't understand what I'm saying now, you guys should, listen previous lecture, okay? I said if you skip the previous lecture, it gotta be, complicated, the lecture, okay? So what I meant is, look at that. The current, which color is better? Okay, the current now this way, right? And since it's dot one way, and the current here, like this, right? So between them, there's I said, repulsion powers happened. Electrostatic repulsion power happened here. So as I said, look at that. Between the contact, there was compression powers enough. You know what I mean? As I said here, look at the switches. Generally, it's closed, so it need to be, contact. But since because of the material, it's cannot be perfectly, contact. As you can see, my hand, there are just some gaps, right? So the metals only that point is connect. You got it? So yeah, let's move on more. So as you guys can remember, before I said the fault current graph, you guys remember? Look at that. The current is, I said asymmetric waveforms happened, right? I will explain about it later, okay? Uh, okay. So different, right? It's not symmetric, asymmetric, right? Because of the if we, I mean, when I will explain later when we start our circuit, yeah, circuit lecture. I'll explain why arc happened and why this fault currents, waveform is asymmetric. Okay, just look at that. So first of all, this point, as I said, look at that. The magnetic force proportional the current is to 2, right? So which means here, look at that, 2. It gotta be really, really, really big. No, sorry. Okay. Really big current, yeah, because of the P, right? So it gotta be really, powerful magnetic force negatively, you know what I mean? Without our intention, it happened because of a fault current. It's kind of accident, right? So look at that. So first one cycle, okay, I'll explain a little bit about the circuit breakers, operating time mechanism, okay? Yellow is better. Okay, here. Around the one cycle, it needed detecting time, right? CT or PT, it needed, detecting time, like a one cycle. Then the relay, then delay runs, operate, and the CT coil operate. Then it start to, open the circuit. Got it? Open the circuit. So it needed a little bit. Here's this one period is a kind of detecting time. And this is, delay time, we say. It depends on the circuit breaker, okay? It's just a mechanism itself, try to understand. Because it needed detect time. Oh, what is the current is that? At least it needed one cycle, right? Oh, it's fault current. And it also needed like orders, right? To the mechanism delay, like, like it needed some delay time mechanically, you know what I mean? So it needed time, then opened. But before we opened the circuit breaker, it have to withstand this at least 2 peak point. As I said, fault current is the first cycle, the first, peak point is the biggest one, and second is a little bit more, third is a little bit more like, and gonna be not fault current, you know what I mean? So it has to, withstand these peak values. So what happened? Look at that. As I said here, the contactor. Here is repulsion powers happened, right? But because of the look at that, the magnetic force proportional, the current is to right. So between them, little bit slightly bouncing happened. We say arcs happened, arc, which means arcs happened. Okay, you guys, this is the result. Okay, this is the first result. When the current flows, and the contact opens, arcs happened. This is the result. Okay, but the matter is when the arcs happened, it also starting welding between the contact. You know what I mean? So what I mean is, if the, as you know, welding is, the two metals, kind of attached, you know what I mean? Make it one conductor, right? So, which means, the contactors, gonna be totally welded. So it cannot, open. Even, the breaker actually needed to open the circuit, but because of the bounce and it arc happened, then welded. So the result is circuit breakers fail. The fault currents just follow to the our electrical facility and makes a mess, really mess. Okay, that's it to understand the CB's basic concept. Thank you, guys. I'm making more useful lectures. See you.